Welcome back. So let's give the solution to the next question. So problem 7. Says, prove the following. So 1, sec theta is given by tan theta plus cosine of theta divided by 1 plus sine theta. Now, to prove a trigonometric identity means that you have to manipulate one side of the equality to show that it has the same form as the other side. So for this given problem, let's play with the right-hand side to show that it simplifies to sec theta. So this is what we have. Now we know that tan theta is the same as sine theta over cos theta. So we can write it as sine theta over cos theta plus this fraction, we write it here the same way. It is cos theta over 1 plus sine theta. Now after converting tan in terms of sine and cosine, let's put these two fractions together. So LCM will be cos theta times 1 plus sine theta. And then cos theta divides LCM 1 plus sine theta times. So I'll have sine theta into 1 plus sine theta plus this divides LCM cos theta times. So I'll have cos theta times cos theta is cos squared theta, which is the same as open brackets here to get sine theta plus sine squared theta plus cos squared theta. You don't have to open this. Let's just the denominator be cos theta into 1 plus sine theta. And then since sine squared theta plus cosine squared theta is 1, then we have, so this part here, sine squared theta plus cos squared theta is 1. So we'll have sine theta just plus 1. This part is 1 over cos theta into 1 plus sine theta. And this same fraction can be written as 1 plus sine theta. Remember, addition is commutative. And then cos theta into 1 plus sine theta. Now this allows you to cross these two brackets which are common. So this and this cancels out, so that we remain with 1 over cos theta. And by definition, 1 over cos theta is what defines sec theta. So which is the same as left hand side. So we have successfully shown that right hand side is the same as left hand side, whose value is just sec theta. And therefore that's the end of our proof. Second part, 7(2), sec squared theta minus 1 divided by sec squared theta is equals to sine squared theta. This is an appetizer. This problem is an appetizer because you will not struggle to show that left-hand side is equals to right hand side this way. So proof. So left hand side, we have sec squared theta minus 1 over sec squared theta. I see when I have A minus B over C, the same as A over C minus B over C. So this can be written as sec squared theta divided by sec squared theta minus 1 over sec squared theta. And this is 1. So we'll have 1 minus 1 over sec squared theta. But since 1 over sine theta equals to sec theta, then this is the same thing as saying 1 over sec theta. 1 over sine is 1 over cos is what is sec theta, not sine. Sorry for that. So since 1 over cos theta is equals to sec theta, then 1 over sec theta is the same as cos theta. So which implies that 1 over sec squared theta is the same as cos squared theta. So therefore we have sec squared theta minus 1 over sec squared theta will be, remember I pick it from here, 1 minus 1 over sec squared theta, which is the same as 1 minus cos squared theta from this relationship here, where there's 1 over sec squared. And this is nothing from sine squared theta, since cos squared theta plus sine squared theta equals to 1. So it goes without saying that 1 minus cos squared theta is sine squared theta. So therefore, left-hand side is the same as right-hand side, and the answer is sine squared theta. And then we rest our case. Lastly, number 8, simplify the expressions. So Roman 1, cosine of x plus pi over 2. Remember, pi over 2 is the same as 90 degrees. Now, by definition, we know that, so solution. Cosine of a plus b is given by cosine of a, cosine of b, minus sine of a, sine of b. So our a will be x, our b will be pi over 2. So this implies that cos x plus pi over 2 will be given by cosine of x cosine of pi over 2 minus sine of x, and then sine of pi over 2. And you see, this will give us cos of x, cos of 90 degrees is 0, minus sine x, sine of 90 is 1. So this will be just 0, then minus sine x. So therefore, the given expression is simply the same as minus sine x. And the last problem, part 2, sine of x minus pi. Remember, pi is 180 degrees. So we know that sine a minus b is sine a cos b minus cos a sine b. This by definition. So sine x minus pi will be sine x cos pi minus cos x and then sine pi. So the thing is that let's get sine cosine of 180 degrees is -1. So this is the same as sine of x times -1 minus sine of 180 degrees of pi is 0 cos x 0. So this will just give us 0. So this reduces to negative sine x. So therefore, sine x minus pi is the same as negative sine of x. So that is what we are supposed to do in that given question and in that given test. Thank you.